When you walk into a dark room and flip the light switch, it feels simple. But that simple action is the last step in a giant global process. That electricity had to be made somewhere, and how it's made has real consequences for the planet. We're going to follow that chain reaction backward and find out the true environmental cost of all the power we use every day. So what does energy use even mean? It's not just big factories. It's you, right now, probably watching this on a device that needs to be charged. It's the hot water for your shower, the refrigerator keeping your food cold, the car your family drives, and the computer server that lets you play Fortnite with someone 1,000 miles away. Every part of our modern world is built on a constant, massive flow of energy. If we need all this energy, where do we get it? Think of our planet as having two different bank accounts for energy. The first is a non-renewable savings account. It's full of fuels like coal and oil that took millions of years to build up, and once we use them, they're gone for good. The other is a renewable checking account. This is energy that gets deposited every day: sunlight, wind, and the flow of rivers. We can use what's in this account, and it will be full again tomorrow. For a long time, we've been living almost entirely off that one-time savings account. Let's look at that savings account. The main players are coal, oil, and natural gas, known as fossil fuels. You can think of them as ancient buried sunlight. Millions of years ago, plants and tiny organisms captured energy from the sun. When they died, they were buried and compressed, and all that solar energy got concentrated into these fuels. The reason we love them is that they are packed with energy. A small amount of gas can move a 2-ton car for miles. The way we get that energy out, we burn them. The problem is, when you burn something, it's like a fireplace. It doesn't just release heat, it releases smoke. When we burn fossil fuels, especially coal, it releases particulate matter, a fancy word for tiny particles of soot. This soot is so small, it can get deep into your lungs and cause serious health problems. It also mixes with other gases to form smog, that thick, ugly brown haze you see hanging over big cities, which makes it hard for people to breathe. It gets worse. When coal and oil are burned, they release invisible gases, specifically sulfur dioxide and nitrogen oxides. These gases rise up into the atmosphere and mix with the water in clouds, creating a weak form of acid. When it rains, it's acid rain. Now, it's not going to melt your skin, but it's strong enough to damage entire forests, kill all the fish in a lake by changing the water's chemistry, and even slowly eat away at stone statues and buildings. This is the big one. The main byproduct of burning any fossil fuel, even clean natural gas, is carbon dioxide, or CO2. For thousands of years, the amount of CO2 in the atmosphere was in a pretty stable balance. But in the last 150 years, we found and burned millions of years worth of buried carbon, releasing all that CO2 at once. This gas is the primary greenhouse gas responsible for a global problem: climate change. So what is this greenhouse effect? It's actually a natural and good thing. Gases in our atmosphere, including CO2, act like a blanket for the planet. They trap just enough of the sun's heat to keep Earth from being a frozen ice ball. The problem is, by adding way more CO2, we've made that blanket much, much thicker. And what happens when you're under a thick blanket? You start to overheat. That overheating is global warming. It's the measurable increase in the planet's average temperature. It might only be a degree or two, which doesn't sound like much. But think about your own body. If your temperature goes up just 2 degrees, from 98.6 to 100.6, you have a fever. You're sick. The Earth has a fever, and it's throwing the whole system out of whack. Global warming is the fever. Climate change is all the other symptoms that come with it. When the planet has more heat energy, the whole climate system changes. It's not just warm, it's weird. Places that were dry get drier, leading to droughts and wildfires. When it does rain, it's often in more powerful, intense storms, causing floods. And all that heat melts glaciers and the ice caps in Greenland and Antarctica, pouring water into the ocean and causing sea levels to rise. The environmental damage doesn't just happen when we burn the fuel. It starts when we get the fuel. To get coal, companies will sometimes use mountaintop removal. This is exactly what it sounds like. They use explosives to blow the entire top off a mountain to reach the coal seam inside. This one act of destruction permanently destroys forests, buries streams, and pollutes the entire watershed with toxic heavy metals from the rock. Getting oil and gas is just as risky. We drill for oil deep under the ocean floor, but if something goes wrong, like the Deepwater Horizon accident in 2010, you get a catastrophic oil spill. Millions of barrels of oil gush into the ocean, killing whales, dolphins, birds, fish, and everything in their path, and ruining coastlines and fishing industries for a generation. And fracking, the process of getting natural gas, uses millions of gallons of chemical-laced water, which can contaminate the fresh water people drink. So if burning fossil fuels is so bad, what about nuclear power? This one is different. It's not a fossil fuel, and it works by splitting atoms, not by burning. Because there's no fire, there's no CO2. It's clean air-wise. It can produce a huge, reliable amount of electricity 24/7. It sounds like a great solution, but it has one giant catch. The problem is the waste. The leftover fuel from a nuclear reactor is one of the most dangerous substances on Earth. It's intensely radioactive and will be for tens of thousands of years. Think about that. The United States doesn't even have a single permanent place to store this stuff. It's all just sitting in temporary concrete pools at the power plants. And if a plant has a meltdown, like at Chernobyl or Fukushima, it can spread that radiation over an entire region, making it unlivable. This brings us to the good guys, renewable energy. These are the sources that are part of the Earth's natural checking account: the sun, the wind, and the water. They are clean. They don't release carbon dioxide or create smog. They are renewable. We will never run out of sunlight. This seems like the perfect solution to all our problems, right? Well, they're better, but they're still not perfect. No energy source is. Let's take solar. To power a whole city, you need a massive solar farm that takes up miles and miles of land. Often, the best place for this is the desert, but that means clearing the existing desert ecosystem. Also, making the solar panels themselves is an industrial process that uses energy and requires mining for special minerals. The same goes for wind. Those giant, graceful turbines are great at making electricity from the breeze, but their long blades can be a deadly hazard for birds and bats that fly into them. And if you live near a wind farm, you might not like the look of hundreds of turbines on the horizon, or the constant whoosh, whoosh, whoosh sound they make all day and all night. Hydropower, using dams, is one of our oldest and biggest sources of renewable energy. But dams have a huge environmental footprint. When you build a dam, you create a giant artificial lake, flooding an entire valley, its forests, and any towns that were there. It also stops a river in its tracks. This is devastating for fish like salmon, which have to swim upstream to lay their eggs. They hit a giant wall of concrete, and the entire population can collapse. So if all energy sources have a downside, what's the most environmental thing we can do? The answer is simple: just use less energy. This is called energy efficiency and conservation. Think about an old-fashioned light bulb. It's a heat bulb that accidentally makes a little light. 90% of the energy it uses is wasted as heat. An LED bulb, on the other hand, is almost all light. By simply switching the bulb, you get the same result, a lit room, for a fraction of the energy cost. The cleanest, cheapest energy is always the energy you don't need to produce in the first place. The big takeaway here is that there's no magic, perfect energy source. Every single choice, from coal to solar, is a trade-off. Each one has pros and each one has cons. Fossil fuels give us cheap power but at the cost of our climate. Nuclear gives us clean power but with dangerous waste. Renewables give us clean power but have their own impacts on land and wildlife. Our goal, as a society, is to be smart about these trade-offs. The solution is to use less energy overall through efficiency, and to get the energy we do need from the smartest, cleanest, and most sustainable mix of sources possible.